Okay, so the one thing that we talked about yesterday, so let's just bring around the rectangle properties one more time. The rectangle is going to have congruent diagonals, okay? But more importantly, what we had for the rectangle was that because those diagonals are bisected, you're going to have congruent pieces, okay? So what that means is this piece is congruent to this piece, is congruent to this piece, is congruent to this piece, okay? So that little piece of information, so we talked about that yesterday. I said, what if this whole length PR was 20? And then we know it's bisected, so these would be 10 and 10. That's what we talked about yesterday. And then we said, okay, well then SQ would also be 20, so these would also be 10 and 10. And that's kind of how we came about knowing that all four of those pieces are equal to each other. So if we look at this part first, this 18, so it says QS is 18. So I'm just going to break that up into 9 and 9, which means this is also 9 and this is also 9. So the two questions we can answer right away are 2 and 4. So ST is going to be 9, and PR, that's going to be the whole thing, 18. Okay, so that kind of helps us figure out the lengths for the diagonals. But now let's talk about the angles. Okay, because we marked all of those pieces, what that made is it made 4 isosceles triangles. So because it's isosceles, if this is 62, then this one is also 62. So let's throw a 62 in there. Okay, now, because this is a parallelogram, all rules of parallelograms apply. So alternate interior, this would also be 62. And because it's isosceles, this one would also be 62. Okay, and then I saw some button pushing on the calculator because we can find this third angle now, right? What's 180 minus 62 minus 62? So if we do 180 minus our 62s, we get our third angle, which is 56. So that's how we got this angle right here, 56, which by vertical is also here. Okay? Now, again, we know about a rectangle. You've been seeing rectangles ever since you were a little kid. So you know certain things about rectangles. But because we are jumping into new properties, we sometimes forget the old properties. Okay, but this is something you know. I know something about a rectangle that makes it easy for me to figure out what this angle measure right here is. If this one is 62, what's this one? Okay, what you know is you know that a rectangle has 90 degrees, right? So the part that you know is we know that this is 90 degrees. We sometimes just forget it because we weren't talking about that specifically yesterday. Like we know that, we wrote that down, but we sometimes just forget. So 90 minus 62 is 28. So that one's 28. Which makes this one 28, which makes this one 28, which makes this one 28. Okay. So the other thing we wrote down on our rectangle page yesterday is that you have 2 pairs of congruent isosceles triangles. Okay, so the top and the bottom triangle and the right and left triangle are congruent to each other, and you can kind of see that with the angle measures here. Then we can find this last angle right here at the middle, right at this T, by doing 180 minus 28 minus 28. Or you could also find that by doing just a linear pair. What's 180 minus 56? Go for it.
I did it kind of the hard way. I did it by 360, so I did 360 minus 112.
Which is both of these, right? Yeah. And then divided it by 2.
By 2.
Okay, and your final answer was?
124.
124. Which is right here as well. Now, we're going to fill out 1 and 3, but I just want you to take a second and see if you can recognize this. This is not essential information, but it's just like, hey, wait a minute. I want you to just take a second. We just found the number 124, right? What is 124 divided by 2? It's 62? What is 56 divided by 2? Yeah, take a guess, right? Now, do you have to know that information to do the problem? No. However, wouldn't it make it easier if you knew that? Just take that number, divide it by 2, and there's all your angle measures, right? So you can keep that in mind moving forward, but again, it's not essential information. It's just like, hey, wait a minute, will that always happen? Yes, it will. Yes, it will. Okay, last little bit here. Let's fill out this QPR. What's QPR? 28? QPR, yep, 28. And then what is PTQ? 124? Okay, moving on. Notice that same as yesterday, I filled out everything on the picture first, and then finding what they need to know is super easy. Okay. Couple more problems here. This is something that you should have seen on your homework last night, but you're going to see it again today. It's which one of the following is this true for? Okay? So name the quadrilateral, parallelogram, rhombus, rectangle, or square for which the statement is true. So which ones are equiangular? Okay, now equiangular, what does that mean again? It means all angles are equal, right? Which shapes have all angles equal to each other? That's our rectangle. And the square. It's not true for a parallelogram. It's not true for a rhombus. But it is true for rectangle and square. Do you remember this one? If you don't, see if you can look back quick and figure out which shape it goes with. The diagonals are perpendicular. And if you're not sure, let me just show you this picture right here. Is it a rectangle? Does a rectangle have perpendicular diagonals? Does that look to be 90 degrees right here at the center? No, so it's not the rectangle. And if it's not the rectangle, you only have one other option, really. Okay, so did you look back? Which one has perpendicular diagonals? The rhombus. Thank you. And then if it's true for the rhombus, it also has to be true for the square. Okay. What about the diagonals bisect each other? This isn't new. And if it's not new, that means it came from the parallelogram. But if it's true for a parallelogram, it's true for a rectangle, it's true for a rhombus, and it's true for a square. Okay, so this is a basic parallelogram property, and if we write down that it is true for a parallelogram, then it's true for all of them. Okay? Okay, last box is a square. And the square is super boring in the fact that it will always be the same as far as the angle measures are concerned. Go ahead, question.
Would we be able to, so if we had a parallelogram, it would count as rectangle, rhombus, and square, but is there any problem where you could still use rectangle, rhombus, and square?
Without parallelogram?
Yeah.
Like property?
Yeah.
Okay, because what we're saying here is we're saying if it's a property of a parallelogram, then it applies to all the other ones. Now, what isn't true is if we go backwards. If I'm looking at a square property, does that mean that that is true for a parallelogram? So if I'm looking at something that only happens in a square, is that true for a parallelogram? No, it's not, because that's a very special type of a parallelogram. Okay, so that's the one we're about to look at. So the question is, can it just be for rectangle, rhombus, and square without being a parallelogram? Well, it could be for a square, which happens to be able to be called a rectangle and be called a rhombus, but that's a very specific type, so it may not work for the parallelogram. Okay, so this is our square, and the squares are this shape that is so special that it's kind of boring. So let's start with this 15. So because we just dealt with a rectangle, this is the same idea. So 15, 15, 15, and 15. Okay, because it's a rectangle. All of those are 15. So same thing that we just did. We took that little number and we put it on all of the diagonal pieces, just like in the rectangle. Same thing for a square. So number 2, FH. So FH is 30. EJ is 15. I'm going to add one, okay, because it was one of the latter problems on the homework from yesterday. I'm going to add one. I'm going to add the question, tell me what the length of EF is. Okay? And before we actually find that, we have to talk about something else. Okay? This is a square, which means it is a rectangle, which is true. We just talked about that. However, it is also a rhombus. And if it's a rhombus, what that means is this. Those are all 90. We just wrote that down just a second ago. Diagonals are perpendicular. That happens for a rhombus. Those are all 90. If that is true, you now have a triangle that is 15, 15, and I want to know what this is. Can you figure that out? Yeah, you can Pythagorean theorem it, right? Before you even grab your calculator, I have the answer. That's a special triangle. If it's 15 and 15 on the sides, what's the hypotenuse?
15 radical 2.
15 radical 2. Now, do you have to know that information to solve the problem? Absolutely not, right? You can grab a calculator, 15 squared plus 15 squared equals c squared, and you can find the answer. But this is where our special triangles come into play. If you have two sides that are the same, the hypotenuse is going to be that number, radical 2. Okay? So, really quickly here, this one right here could be 15 radical 2, or it could be something else as well. Okay, so there are a couple of problems that it'll say keep it as a simplified radical, but if you wanted to use your calculator, you could still simplify the radical at the end. So 15 squared plus 15 squared is 450. It's really hard to see that. It's 450, and then you would take that 450 and you would simplify it down. So divide it by 4, divide it by 9, divide it by etc. Okay, until you got something that worked. Okay, so this is either 15 radical 2, if we needed to leave it in simplest radical form, or 15 radical 2 as a decimal is 21.2. But again, because we don't have that right in front of us, we sometimes forget. Like, you know that. After we said it, it was like, oh yeah, we know that. However, because that's not exactly what we learned yesterday, we sometimes forget that we can use that here. Okay, so let's talk about the angles. So this is where I think the square is super boring, because the angles are always the same no matter what. So we just talked about that that's a special triangle, and if that's a special triangle, and this is 15, 15, and 15 radical 2, what did these angles have to be? What kind of special triangle has x, x, and x radical 2? Do you remember? 45, 45, 90. So these are all 45, 45, 45, 45, 45, 45, and 45. That will always be true for the square. Why? Because it's a rhombus, and a rhombus has diagonals that bisect the angles. I know these angles are all 90. So if I take those 90 degrees and I bisect them, they all have to be 45. So EJF, that's one of our 90s, because it's at the center, perpendicular diagonals for a rhombus. JFG is a 45. There you go. So we're not moving on to anything new today because there's a lot of information to process about the rectangles, the rhombus, and the square. So we're going to practice that one more time. So if you want to grab out your homework from last night, and then I'll get you the one